All right, so the first part of these notes are about solubility. Now, the definition of solubility is how much can dissolve. In general terms, there is something called a solute, and that could be something like sugar or something like salt, but in chemistry, it could be something like copper chloride, just a bunch of different things. But that solute is the solid, and it is going to dissolve in typically water, but it's called the solvent. You can dissolve in other things, not just water. You can dissolve in alcohol. You can dissolve in hydrogen peroxide. But in this scenario, and in most scenarios, things will be dissolving in water. Well, once you've combined the two, then you get something called a solution. Solutions are when the solute and the solvent have combined. Solubility is how much can dissolve. And how much can dissolve will always vary based on the temperature. So, the different factors that can affect dissolving, one that I already discussed, is that if I have temperature change, then the dissolving will change. Now, if you think about sweet tea, right? Most people, when they're making sweet tea, use warm water or hot water. The reason why they do that is because if the water is hot, then a lot of sugar can dissolve. If the water is cold, not a whole lot of sugar can dissolve. And that is because the temperature increase will allow more particles, more sugar to dissolve. So the first thing is an increased temperature will increase dissolving. The second thing that people do when they're making sweet tea is they mix the container. They mix the solution. Now, the reason why they mix is because the mixing will make the particles collide more. And if you remember in gas laws, if they collide more, that means there's an increase in pressure. Now, the fact that they are colliding more, that there's an increase in pressure, will cause them to also increase in their dissolving. People mix when they make sweet tea so that the sugar can dissolve faster, right? So, and here's the way you get the increase in pressure is by mixing. The last thing, again, if we're going to think about sweet tea, is instead of using a humongous chunk of sugar, people typically use the sugar that are in small grains. Now, the reason why they do that is because more surface area is exposed. Look at this picture right here. This first picture would be like you using a humongous chunk of sugar. Well, the only exposed area are the sides of the box, and that's not a whole lot. But if you break up that sugar into smaller pieces, you get all this exposed space. The four sides of each box are exposed. That's more surface area. Well, the last picture has even more sides exposed. And because more sides are exposed, the sugar can dissolve even faster. So, this is called increasing surface area, increasing dissolving. The way we increase surface area is by breaking something up. Just like sugar, you can break it up into smaller pieces. All right, so when we're talking about a solubility curve, there are different areas of the curve. Now, if we look at this graph, the x-axis is temperature, and temperature is increasing from left to right. The y-axis is how much can dissolve if I have 100 grams of solvent. Remember, solvent is typically going to be water. So if I notice this graph, it's increasing as temperature goes up because, as we just said, the higher the temperature, the more things can dissolve. Okay. Now, let's say that there's a point right on this line. If it's right on the line, then that means we are saturated. It means we've added just the right amount, and that can all dissolve. If we're a point above the line, anywhere above that line, we're supersaturated. And supersaturated means that you added way too much. Now things aren't dissolving. The stuff that's not dissolving are forming crystals because they couldn't dissolve. If it's a point underneath the line somewhere, it's called unsaturated. Unsaturated means that you haven't added enough. And because you haven't added enough, you could technically add more and it will still dissolve. So that's how we look at this graph. Now, the way we're going to look at graphs is the question will always give you a compound to find. For example, it'll tell you to find NaNO3. And then we look at that curve, but then we note the temperature of the curve. So for example, at 20 degrees Celsius, we are at 85 grams. Now, what does that mean? That means that 85 grams of NaNO3 can dissolve if there's 100 grams of water. That's what the y-axis says. But if I increase the temperature to, say, 80 degrees, then at 80 degrees, about 145 grams of NaNO3 can dissolve in 100 grams of water. So even more sodium nitrate can dissolve in water because I've increased the temperature. Most lines increase like that. But what's special is that this line down here, SO2, sulfur dioxide, does not do that. It actually decreases. And that's because sulfur dioxide is a gas. Most gases will actually decrease in their solubility as the temperature increases. Okay, here's an example question. How much KNO3? Well, now we know to look at the KNO3 line right here. And it says dissolves in 100 grams of water. The 100 grams of water is what we see here at 50 degrees Celsius. So we're going to look at 50 degrees Celsius. We're going to note that that is right here. And that is about 85 grams of KNO3. It's okay if you don't get the exact same number as me. If you say 84, it's fine, so long as it's close to 85. All right, next question though says, how much KNO3 dissolves in 200 grams of water at 50 degrees Celsius? So notice the temperature is the same. What's different between the two questions though is that this first question has 100 grams of water. Second question says that you're doubling the amount of water. If you've doubled the amount of water, then even more KNO3 can dissolve. How much would be, well, if this is doubled, then the amount that can dissolve could also be doubled. So 85 times 2 would give us 170 grams. The next question, though, says dissolves in 50 grams of water at 50 degrees Celsius. So same temperature, same substance, KNO3. But yet here, we don't have as much water. We only have 50 grams of water. So the difference between 150, that is just divide by 2. So you have half the amount of water. So that means half the amount can dissolve, which would be somewhere about 42.5. Again, doesn't have to be exact, but 42.5 grams is what I get. Okay, that's how you answer questions like that. This question says an unsaturated solution, remember unsaturated means that not enough dissolved, is formed at 30 degrees Celsius. So let's look at the HCl line and let's look at 30 degrees Celsius, right about here. That's like 65 grams. Okay, but it says that you added 40 grams of HCl. How much more HCl should be added to make a saturated solution? Saturated is on the line, but yet you've only added 40 grams. You could add 65, you've only added 40. So how much more could you add? You just subtract to find out. You have 40, you could add 25 more grams to get yourself to 65, and then you would be saturated. Next question, a saturated solution of NH4Cl, so let's find that line, is formed at 90 degrees Celsius. If we cool the solution down to 70, not as much will dissolve. Determine how much less will dissolve. Well, okay, let's figure it out. At 90 degrees Celsius, we're right here, which means about 70 grams can dissolve. But at 70 degrees Celsius, we're right here, which means 60. 7 degrees Celsius, about 60 grams can dissolve. Well, you were at 90, 70 grams dissolved. Now you're at 70 degrees Celsius, only 60 grams can dissolve. So how much less NH4Cl is dissolved? You again subtract and get 10 grams. 10 grams would be not dissolving because of the cooling down in temperature. Right? Keep watching. The back side of your notes is going to be for your new notes. This part of the notes is on something called molarity. Now, molarity will require you to have out a periodic table and a calculator. So make sure you have those two things. All right. So molarity definition is the concentration, how concentrated something is. So let's look at this picture down here at the bottom. This box on the left is the same size as this box on the right. But even though they're the same size, there are more black circles on the left box. So there are more black pieces. Those black pieces are more concentrated on the left-hand side. On the right-hand side, not as many black pieces, so there's a low concentration. So let's say that you have sugar and you pour it into a teeny tiny container of water that's going to have a very high concentration. If you take that amount of sugar, the same amount of sugar that you poured into the tiny container of water, and you poured it into something humongous like a swimming pool, well, that's not going to be very concentrated because you have a whole lot less sugar compared to the amount of water that it is in. The equation for this is molarity equals M. So this capital M stands for the word molarity. It's different than the little lowercase m because the lowercase m stands for mass. So don't get those two confused. Okay? M equals moles over liters. Moles of solute, this is what's doing the dissolving. This is the one that gets the dissolving, like sugar. Liters of solvent. Solvent is the one that's doing the dissolving, like water. Now remember, though, that this has to be in liters. So a liter is 1,000 milliliters. So for example, if you have 3,850 milliliters, you divide by 1,000, and that gets you 3.85 liters. Volume has to be in liters. Just like in gas laws, we needed it to be in liters. Here's a first practice. Find the molarity of the solution. So we're finding molarity. We don't know the big M. If you have 6.61 moles, well, I have this. I'm going to plug it into the top part of the equation, moles, in 3.0 liters of water. So I'm going to plug that into the liters part. 3.0 liters, and now all I have to do is solve. So basically what this question is saying is if this amount of NaCl, which is salt, dissolves in that amount of water, how concentrated is the solution? The answer that you should get there is 2.2. Your unit is going to be the capital M, that stands for molarity, also called molar. Number 2. To make 2.4 molar solution of NaCl, how many moles of NaCl must be added to 2 liters of water? Well, here, you have the molarity in this case, 2.4. You do not know the moles. So I'm just going to write moles. You do know the amount of water, 2.00 liters. So now you're just going to solve. Now remember, if you want moles by itself, you need to get the 2.00 liters out from that side. So I'm going to multiply both sides by 2.00 liters. That causes the right-hand side to cancel out. And on the left-hand side, I would get 4.8, and that would equal my moles. Okay, now the next question says, convert this answer to grams of NaCl. So what you do know, though, is 4.8 moles of NaCl. So all you have to do is convert like you've always done. Moles is on top, so I'm going to get rid of moles by putting it on bottom. I'm going to put 1. I want to find grams, so I'm going to put grams on top. Now, the way I know what number goes here is I find the weight of NaCl. I find the molar mass of NaCl. That is 58.44 grams. I do my math, and the answer is 280 grams. This question was broken up into 2 parts, but the question could have just said, to make a 2.4 molar solution of NaCl, how many grams of NaCl must be added. So you would need to do 2 steps. First, just figure out the moles like we did, and then take moles and convert to grams. Take a moment to try this question yourself. In this question, what's different is you're finding the molarity, so you're finding this part. All you know, though, is 31.1 grams of aluminum sulfate and 0.913 liters of water. So you know the liters of water. That's 0.913. You don't know moles, though. So here's what you have to do. Take 31.1 grams and convert to moles first. That's here, 31.1 grams. The molar mass of aluminum sulfate was 342.17. I get this answer. Now that I know moles here, then I can plug that into the equation. And I get a final answer of 0.0996. Okay? Take a moment to try the next question. Here, you don't know the volume, but you do know 0.95 molar. You know 48.4 grams. Well, you don't know moles, but you can convert 48.4 grams to moles. So here's the work for that. I first convert grams of CaCl2 to moles. And once I know that, then I can plug in, well, 0.95 molar, 0.436 moles, and then I'm going to solve for liters. If you're solving for liters like that, you multiply both sides by liters. And what you're left with is 0.95 times liters equals 0.436 because the liters will cancel out. Here, I still need to get liters by itself, though. So now I'm going to divide both sides by 0.95. Now, liters is by itself, and my answer should be 0.46 liters. Here are the answers to number 6, number 7. Oh, just kidding. That was it. You should do more practice, though, on Canvas or on the worksheet if it was printed for you.